Good afternoon. We have discussed about the CI engine combustion in the last lecture, and in continuation of that today we will discuss about the CI engine injection system. That is also an important part for the engine operation, and we will see what are the different injection systems typically used for the CI engine operation. So, now we will see the CI engine injection system. So, if we recall that we have discussed there are different methods available for the SI engine injection system, and we have discussed different methods. In a similar way, the CI engine injection system can also be classified into different categories. That for the SI engines we have discussed about single point fuel injection, multiple point fuel injection system, and also we have discussed about the electronically control unit. Now, for the CI engine also we can classify the CI engine injection system. We need to know that for the CI engines we are using, rather engines are equipped with a fuel nozzle and fuel is injected into the engine cylinder depending upon the depending upon the engine load. So, the CI engine injection system should have a few important objectives. Engines are equipped with the fuel nozzle. Fuel nozzle will be designed in such a way that the nozzle will be capable of supplying required amount of fuel which is demanded by the engine. So, the CI engine injection system, which the system is having a few equipments like fuel nozzle, metering system, fuel pump. So, the entire injection system is designed to supply required amount of fuel depending upon the engine load. So, before we go to discuss about the injection system, at least we should know what are the different objectives behind this injection system. So, I can write different objectives of the injection system. So, we will write number 1 is metering the quantity of fuel . So, before we go to discuss about different objectives, it would be helpful if we try to draw the injection system schematically. So, I can draw now that this is engine cylinder, this is top dead center, this is bottom dead center, and piston is having. So, if I try to draw this, now and so this is rotating like this, Now, so this is the points A, this is the point B, and fuel is supplied by a fuel nozzle and it is coming from fuel chamber. So, this is pump, then we will have strainer, we will have small pump, we will have strainer, and that will come from the fuel sum. So, that will come from the fuel sum. So, this is pump 1, that is low pressure pump, this is pump 2, that is high pressure pump, these towards the strainers, and this is reservoir, and this is fuel supply line. Right. Now, point A, this point A when, so now we can see from the schematic that fuel is taken from reservoir, then of course, we need to strain out the foreign elements which are expected to be there in the reservoir, and then because if we allow foreign particles to go into the nozzle, they will try to clog the nozzle, fuel nozzle. So, we have two different strainers to separate the foreign particles, and for that we have a small pump, low pressure pump, and finally high pressure pump is used to overcome the pressure, to build the pressure which is required to inject fuel in a desert spray pattern. Now, the fuel injection, if we try to recall now, the fuel injection will start so that the maximum pressure that will be developed inside the cylinder, that is 50% of the maximum pressure will be developed, or I can say 50% of the total pressure that will be developed before piston reaches a TDC. So, that is why when piston is travelling, so piston movement is between these two locations VDC and TDC. Now, the fuel injection starts at point A. So, this is fuel injection starts, and injection continues until piston traverses back from TDC towards VDC during the expansion stroke, and that is why the fuel injection continues in this region and B is the fuel injection stops. Right, and this angle is near about 50 degree. So, 20 to 25 degree before TDC fuel injection starts, and it continues after TDC by an amount 20 degree or 25 degree of the crank angle. So, the total angle of injection, that is 50 degree, and that is, I can say, theta, that is the fuel injection period, fuel injection angle. Now, so this is what we have seen. So, this is the schematic depiction of fuel injection system. What we can now discuss, that what are the different objectives of having this system. First one is metering the quantity of fuel as demanded by the speed and load of the engine. Number 2. So, this is the first objective. Similarly, number 2 is I can write distribute the metered fuel equally among the cylinders for multi-cylinder engines. Normally, CI engines are basically heavy vehicles. Heavy vehicles are basically having compression ignition engines. Now, for that heavy vehicle we need to have multiple cylinder. So, the objective of metering system is not only to meter the quantity of fuel which is required rather as demanded by the speed and load of the engine. Instead, rather I can say it will also have another objective, that it will distribute the metered quantity, the metered fuel equally among the cylinder for multi-cylinder engine. Number 3 is inject the fuel at correct instant in the cycle. So, maybe we can distribute the metered fuel among the cylinder, but now the fuel that is metered and distributed will be injected into the cylinder. So, that would be another objective. Not only that, inject the fuel at correct instant in the cycle. So, that is the injections time we have. When we design a engine, either a CI engine or SI engine, we need to supply fuel for a desired amount of time, and that is why it is very important that the metering system will be able to inject fuel at correct instant in the cycle. Number 4 is inject the fuel at correct rate. Of course, that means the injection system will be able to supply the correct rate. It should not supply lesser than the design value or higher than the design value. Then we have seen, if it is less than or higher than the stoichiometric value, chemically correct value, then fuel air mixture will be either linear or richer, and it is very difficult to sustain the flame. So, combustion won't be completed. Number 5 is inject the fuel with the spray pattern and atomization demanded by the engine. And number 6, which is very important, begin and stops injection sharply. If we cannot ensure that the fuel injection will start and stop sharply, then we will see that there is another problem which is known as after injection in the context of CI engine in operation, and that will leads to another problem that we will discuss maybe in the next class. So, these are the different objectives which should be taken into account while designing the CI engine injection system. Next, so these are the different injection these are the different objective system. So, to accomplish these objectives we need to know, rather we need to have a few functional elements, and then what are the different elements we should have in the injection system, rather our injection system should have, we need to know. So, I can write two these objectives CI engines following functional elements I can write. Right. Number 1 is required, that is pumping element. For the transportation of fuel from tank to the cylinder. Number 2, metering element to measure and supply the fuel depending rather as demanded by the speed and load. Number 3 is metering controls to adjust the rate of metering elements for changes in load and speed of engine. Number 4 is distributing element to divide the metered fuel equally among cylinders. And number 5, tuning elements to adjust the start and stop of the injection. So, these are the different elements CI engine fuel injection system should have. So, now knowing the objectives and to accomplish the objectives required, the number of elements required in the injection system we have seen. So, now we will try to see what are the different types of injection systems typically used for the CI engine combustion. So, these are the I can say types of CI engine injection system. What are the different types? Broadly, the CI engine injection system can be classified into two categories. One is the air injection system and number 2 is solid injection system. The solid injection system can be further subclassified into three categories. Common rail system, individual pump and injection, I can say nozzle, and number 3 unit injectors. So, these two important types are available, air injection system and solid injection system, but air injection system is not used, but solid injection system is used, and the solid injection system can be classified into three subcategories: common rail system, then individual pump and nozzle, and finally unit injectors. The solid injection system, now I can tell for the solid injection system here pump is used to compress the liquid fuel, but the air injection system will be using compressed air rather to swap the liquid fuel which will be injected into the injection system. So, this injection system this is due to Dr. Rudolf Diesel. Dr. Rudolf Diesel, who invented the diesel engine first, and to honor the name of this great scientist, this cycle or engine is known as diesel engine, and also the cycle or air standard cycle which is used to analyze the thermodynamic processes of this diesel engine is known as diesel cycle. So, that what is done, this in this injection system, just I am writing, this is not used nowadays because an important problem, but say if this is engine cylinder, then fuel is, that is the combustion product which is going out from the exhaust valve. Now, fuel will be swapped by connecting one high pressure air supply line. So, this is So, we need to have one compressor and this high pressure supply line. So, this is air compressor, and so fuel is taken in this point, not nozzle. So, this is fuel supply line. So, fuel is taken through the fuel supply line into this point, and when fuel is just coming out from the fuel supply line, and high pressure air supply line, rather high pressure air is used to swap the fuel into the cylinder, and the high pressure air is also used to atomize the fuel into finer fuel droplets. So, this was the concept of the air injection system. So, here the injection system is not equipped with any additional pumps, so that the pressure drop that is required, the pressure we need to overcome the pressure drop in the nozzle, and the pressure is built up by the pump in the injection system. But this air injection system is not having additional pump, rather fuel is taken through the fuel supply line into a point where high pressure supply high pressure air supply line is connected. So, the compressor is used to build up the pressure of the air, and that air together with the fuel which is supplied into the cylinder, and the required amount of air fuel mixture is supplied. So, that was the concept of the air injection system. So, we are getting air, and the incoming air which is swapping the fuel which is coming out from the fuel supply line. Not only that, the high pressure air is atomizing the fuel droplets, liquid fuel droplet into a number of fuel smaller fuel droplets. Now, question is, so this is TDC. So, this is top dead center, and this is bottom dead center, and this is the piston. So, this is the concept, this was the concept of the air injection system. Now, question is, this system is not used, but there are a few problems that we need to run this high pressure. So, to run high pressure, we need to extract energy from the power which is developed from the engine cylinder. Not only that, the air velocity which is required to swapping the fuel which is coming out from the fuel nozzle, as well as to fragment the fuel particle into a number of smaller fuel particles, the pressure that will be developed by the compressor is very high. So, to develop that high pressure, the size of the compressor will be increased, and to run that compressor as well as to equip that compressor in the engine, I mean a substantial part of the, I can say, output, power output will be utilized, and this is a kind of parasitic load that we have discussed in the context of engine operations in one of my previous classes. So, this is not used nowadays. Instead, we will be focusing our attention on the solid injection system, where we have seen, rather we have written that a separate pump is used to develop or to compress the liquid fuel. Rather, we need to pass fuel through fuel nozzle, and to overcome the pressure drop that will be there in the fuel nozzle depending upon the design, I mean depending upon the load and power demanded by the engine. So, that to overcome that pressure, a pump is equipped in the injection system, and that is what we have seen just today in my last slide. So, this system is classified into three different categories. One is common rail system, other one is the individual pump and nozzle, and third one is the unit injector. So, today we will discuss about the common rail system. and we will see that what are the, in fact we will try to discuss this common rail system through a schematic depiction. So, if we try to draw the schematic of the this common rail injection system, we will see that again we will have pump, then we will have strainer, then we will have one special part of the system which is known as common rail, and then from there the fuel is supplied into supplied to the two different cylinders if it is multi cylinder engine. So, we have one so this is fuel reservoir which is fuel is taken, then we will have one strainer, then as I said we will have one pump P1, that is low pressure pump. Then again it is fuel is taken to another strainer, and then from there we have one high pressure pump P2, and then fuel is taken to common rail. So, this is known as common rail. It is a kind of I can say header where the high pressure fuel is stored, and from this common rail fuel is taken to the metering elements, and there are different metering elements, and from each metering element fuel goes to cylinders. To cylinder. Now, this is known as metering element. Common rail basically it is common reservoir, right. And if the pressure of the common rail exceeds beyond its design value, then the fuel is taken back to the high pressure pump through throttling. So, this is throttle valve. If pressure in the common rail exceeds beyond a critical value, then fuel is throttle valve. That means, the objective of this throttle valve is to maintain a constant pressure in common rail. So, this is the schematic depiction of the common rail system. We have seen the different parts, that is what we have discussed in the beginning of this course. What are the objectives we should have when we are talking about common rail injection system. And now, question is, when fuel is coming from metering element to the cylinder, then of course it will be discharged not not in a liquid form, rather as we have discussed that the fuel which will be supplied into the cylinder will have I mean spray pattern. So, to have to maintain the desired spray pattern which will be supplied by this injection system into the engine cylinder, we need to know the, I mean we have schematically depicted that from metering elements we have, if we have 4 metering elements. So, we can distribute fuel to 4 different cylinders, but if we try to now draw the enlarged view of the metering element by how we can supply required quantity of fuel depending upon the engine load and speed, and then we will come to know the mechanism of fuel injection using this common rail injection system. So, if we try to draw the system that, so we have cylinder, so this is lifter, this lifter determines whether rather when the injection starts and period of injection. So, we can say that the needle, so this is the needle, the general tendency of the needle will be to remain seated on this orifice. So, orifice will remain blocked in normal condition. We need to lift the needle by the lifter, and that will be operated by the cam and follower, which will be connected to the engine cylinder. Now, this is high pressure so this is say, so this is 2 and this is cylinder and say this is 0.1. So, high pressure fuel supply line from the common rail, and this is leak return. To the reservoir. So, this is the case. So, high pressure supply line is coming, this is the metering element. Now, what we can see that the needle is connected with the needle is having spring loaded valve, that is the needle is basically spring loaded valve. So, the normal tendency of the needle will be to remain seated on the orifice, so that the fuel passage will be blocked. Now, when high pressure fuel is coming from the fuel supply line, and then now if I try to draw the this is basically line. So, the high pressure it will have two different components. So, the vertical component of the force, because of this high pressure fuel supply that is striking the needle wall, we will try to lift the needle by an amount and very small amount, and because of this lifting of the needle, the high pressure fuel will be injected into the cylinder. So, this is the mechanism by which we can have fuel injection into the cylinder. Now, question is, high pressure fuel which is supplied or which is striking the needle, or maybe all the fuel which is coming won't be able to enter into the cylinder, but the remaining amount of fuel can be taken through the leak return port into the reservoir. Now, question is, that is this is vertical component, this is horizontal component. So, the force which is because of this high pressure fuel which is coming from the fuel common rail, it will strike the needle wall. Now, the vertical component will try to lift the needle by an amount which is very small, of the order of millimeter, and through which the fuel will be injected into the cylinder and will get the desired amount of fuel. And if excess fuel is there, that excess fuel will be taken through the return port into the reservoir again. So, I have drawn two different cross section, that is cross section 2 and cross section 1. So, if I now try if I say write the steady flow energy equation between these two section 2 and section 1, what we can write, that at the time of injection pressure. So, at the time of injection pressure P1 is the pressure inside the cylinder, and pressure at the end of the needle is 2. So, if I now try to write the steady flow energy equation between these two sections 2 and 1, then we can write P1 by rho f plus C1 square by 2, and that is very important to know, because C1 is essentially an indication whether we can get desired spray pattern or not, whether we will get the finite droplets or not. C1 square by 2 is equal to P2 by rho f, and we can write C1, that is nothing but 2 into P2 minus P1 by rho f under root, and therefore, mass flow rate of fuel in kg per second that will be equal to rho f into A1 into C1, that is nothing but A1 under root of twice rho f into P2 minus P1, that is delta P. So, that delta P that will be developed by the pump, and that is why this high pressure pump is there, or that pressure is maintained at the common rail system. So, this will give us the estimate of the fuel flow, the mass flow rate of the fuel that is being injected. Now, question is, if you go to the next slide, say if T is the time for the injection, and theta is the angle of injection. So, that is what we have. If we try to go back to the previous slide where we have seen the theta, this theta is the angle over which fuel is injected into the engine cylinder. Now, theta is the angle of injection, and if n is the RPM of engine, then we have calculated mass flow rate of fuel, that is nothing but A1 under root twice rho f into P2 minus P1. So, if this is the case, then we can write that 360 degree, that is of crank angle revolution, crank angle rotation is equal to 1 revolution. So, that means if the RPM is n, then we can say n revolution in 1 minute, that is 60 second. Therefore, 1 revolution will be equal to 60 by n second. So, per revolution will have 60 by n second time. Now, if theta is the angle of injection, so this 360 degree, that is 1 revolution, that is nothing but 60 by n second if engine speed is n RPM. So, if theta is the angle of injection, then the theta will be equal to that for theta angle of injection, it will be 60 by I can say 360 into n into theta second, that is nothing but theta by 6 n second. So, if theta is the angle of injection, if n is the RPM of the engine, we can say the amount of fuel that will be injected, that is nothing but theta by 6 n second. So, we will discuss that, we will do little bit more mathematical exercise to see that the kg of fuel which is supplied per cycle, which is nothing but the 1 by RPM, and from this we will see why diesel engines are more suitable to run electrical generator, why diesel engines are preferred. So, to summarize today's discussion, we have started our discussion with the CI engine injection system. We have discussed about the objectives of the CI engine injection systems, and to accomplish the objective, what are the important or the functional element the CI injection system should have, we have discussed. Then we have discussed the classification of the CI engine injection system, and we have seen that the injection system can be classified into 2 different categories: air injection system and the solid injection system. Solid injection system can be further classified into 3 different categories, that is common rail system, individual pump and nozzle, and finally unit injector. We have discussed about the mechanism of air injection system and why this injection system is not used nowadays, that is also we have discussed. And finally, we have discussed about the common rail system with the schematic depiction, and we have seen that the amount of fuel, that the time of injection we can relate in terms of the RPM of the engines and the crank angle of the injection. And we will discuss, from this discussion we will see that why diesel engines are preferred for to run the electrical generator, and also we will discuss about the individual pump and nozzle system and the unit injectors. We will see their mechanism as well as their the difficulties associated with the with those injection system. So, those part we will be discussing in the next class. So, with this I stop my discussion today and we will continue in the next class. Thank you.